Okay, this is your last homework assignment. And what we're going to be working on here is a problem that involves linear regression analysis. And in this case, we've got both categorical data that we're going to be working with, as well as some quantitative data. So if we look at the question stem, it says the U.S. Department of Energy's Fuel Economy Guide provides fuel efficiency data for cars and trucks. Portion of the data for 311 compact, midsize, and large cars is below. So let's just take a quick peek at that. This right here is the original data set, and it goes down about 300 lines, right? So 311 observations, and it's large, mid-size, and compact cars, and you have data on displacement for the engine and fuel type and the highway miles per gallon for each one of those cars. Okay. The class column identifies the size, the displacement column shows the engine's displacement in liters, the fuel type shows whether the car uses premium or regular, and the highway miles per gallon shows the fuel efficiency rating for highway driving in terms of miles per gallon. So you got to do A through F. There's quite a bit of work here. I'll try to chop up the videos so we don't have too much going in one video and spread this out a little bit. But first, what we're going to do is develop a regression estimate equation that can be used to predict the fuel efficiency for highway driving given the engine's displacement. Then we'll test for significance using a 5% level of significance and assess how much of the variation in the sample values does this regression equation explain. So we're only doing the highway efficiency as your y-axis and the engine's displacement, which is a quantitative variable. So we don't have to do anything yet with respect to the dummy variables. We'll get to that in a minute. So this is your x variable and this is your y variable. What I did is I just took the data that you had here and I copied that over. If you set it up where you got x on this side of y like that, then it's easier to run your regression. Just makes it a little cleaner, especially when we get into multiple x values. You'll see what I mean. So I've done that for you for each one of these. I've copied the data over, so it's real handy. So here we go. We're going to do data analysis, regression, and then you got to get your data points. You're going to have to edit these. So go over to A. First one is Y, so get Y. You can highlight it this way, or you can use the shortcut keys. Okay. So you just, okay, good. X, highlight that, get rid of it, and scroll over and get the X values. Yeah, so if you hit Shift Control down arrow, that'll do that. Okay, let's tell it where we want it to be. So we would like that. Careful with these. Right there would be perfect. Okay, now let's look at this. So 4 things. You got the Y, you got X. I don't have the labels highlighted, so I'm going to take that off. You got the output range where I'm going to set this down, and I'd like the residual plot. So it's perfect. Looks good. Okay, so there's my chart up there. I'm going to pull that down. Okay, and then this is also important. So slide that over and rearrange our charts a little bit. Okay, here we go. All right, so the R squared here is around 69% of the regression can be explained by looking at the displacement. And then these are the coefficients on the equation with the corresponding p-values and t-stats. Okay, so both of these are significant. Notice that the confidence intervals do not include 0. So they're both significant values. The equation would be y equals 35 point, let's go 4 decimals, 3950. That's the intercept, which comes from right here, the coefficient. Oops, and then the slope is the x variable right here, minus 2.8821 x1. And that's displacement. And if you want, you can change that and call it displacement because the x variable is displacement. Okay. And then looking at the residual plot, Although there's nothing there that really concerns me, it looks like there's the potential for different variances that exist across the data, but I don't see it frequently enough to concern me, right? So I'm not saying, remember that one graph I showed you, I kept them here to show it to you, where you see that fan, that's definitely a problem, something like that. So there is a little bit of evidence of that problem, but nothing that really scares me in that. Okay, so the equation, oh, that's fine. Let's just say 35.4, that's good, right, 0.4. Minus 2882, that's fine. Because sometimes when you run these, you get little different rounding errors. Haven't figured out why yet. It's okay, they're all, as long as they're close enough. All right, and that looks fine for the R squared. So we're getting an equation, and I'm looking at the residuals, and I would say they don't lead me to any grave concerns about making conclusions based on these p-values, inference of these statistics for the equation. So I would say that this is a fairly decent equation. We could maybe improve on it a little bit because our R squared here is only 69%. So obviously there's other factors besides displacement that have an impact on the highway miles per gallon. So we're going to take a look at that next. Okay, so what it's asking us to do in B, so I encourage you to read through this. It just talks about making inferences based on these statistics. In B, we're going to create a scatter chart with the highway miles per gallon on the y-axis and displacement on the x-axis, for which the points representing compact, mid-size, and large automobiles are shown in different colors, shapes, and or colors. We haven't done that yet, so it's a great chance for us to take a shot at that. And then what does the chart suggest about the relationship between the class of automobile, compact, mid-size, large, and highway miles per gallon? All right, so for B, what I did for you is I brought over all the observations. I put in the compact field. Notice that they're already sorted for us, which is cool. Compact is all together, and then the large are all together. And that's what you want when you want to do a scatter chart that's got different colors in it. Okay, so we'll go ahead. When you go to put this chart on, only highlight the compact, because then we can add a second series and a third series for the midsize and the large. Okay, so we're going to highlight just the compact. Right there. Insert scatter chart. Okay, and I do want to bring that up. There we go. Perfect. Okay, so then right mouse click on this and select data. So that series right there was for compact. Let's name it. Okay, so just change the name here to compact. Now, if you add a second series, we'll name that midsize. And we got to go get the X and Y values separately. So the X, remember, is displacement. So go down to midsize and highlight X for just midsize. Displacement midsize. And then the Y for midsize only. Okay, and then add a third one for large. Get the X values. Nice and short. And the Y values. Okay, so we got all three. Let's take a look at it. All right, that's exactly right. You can add some, if you go to quick layout, add some axes total. So remember that this is highway miles per gallon. And this one over here is oh, sorry, that's my bad. This is highway miles per gallon is Y, and the X is displacement. There we go. All right. And then this chart title. So that's a really cool way to do a scatter graph of some data points and add a third dimension to it. So this is a two-dimensional chart, but you can add that third dimension by coloring them up. And the only way to do that is to do a series, one series at a time. But it's a really powerful graph. So it's kind of counterintuitive too. It's telling you that the mid-size cars, they have better highway miles per gallon and less displacement. And the compact cars have more displacement and less miles per gallon. So when you're looking at displacement, it's actually relevant with respect to the efficiency of the car. Okay. So I'm going to stop this video right there. I think that's kind of a good spot for you to take a break and look through this. There's a good explanation here in terms of what's going on with this graph to give you that insight about why the midsize might be different. So I hope that makes sense. And I'll start the next video and work on C and D. And then probably we'll see how long that goes, and I'll try to do E and F with you. So I'll show you how to add those categorical influences to give you some more insights on the data. Okay.